Welcome my dear learners for this course on engineering graphics. In this module 2 we were discussing on orthographic projection of plane surfaces. So far we have solved 14 problems on our discussion on orthographic projection of plane surfaces. Moving ahead, the problem number 15 of our discussion states that a pentagonal laminae of edges 25 mm is resting on HP with one of its sides such that the surface makes an angle of 60 degree with horizontal plane. The edge on which it rests is inclined at 45 degrees to VP. Draw the projections. So we have a pentagonal laminae of edges 25 mm resting on HP with one of its sides. So it is resting on one of its edges. So therefore, in the initial position I should draw pentagon such a way that I will get edge towards my left hand side. This is because we are using left hand reference and always we are rotating the second position front view in the counterclockwise direction in order to avoid confusion in the orthographic projection of plane surfaces. Come, let us solve problem number 15. Let me draw XY line first. So we have XY line and the pentagonal laminae is resting on one of its edges. So therefore I will take edge towards my left hand side and the dimension is known to us. The dimension is 25 mm. So I will draw 25 mm. Now using compass I will mark 108 degrees interior angle. So from the line if I measure it is called interior angle. Opposite to the line if I measure it is called exterior angle. So interior angle is 108 degrees and exterior angle is 72 degrees. So similarly mark in the opposite corner also. So now this will become interior angle and this will become exterior angle. Interior angle is 108 and exterior angle is 72 marked. Now draw the edges. We know the edge length is given as 25 mm. So draw 25 mm. Here also you draw 25 mm. Drawn. Now using compass you cut arc. Using compass you cut arc from above and also from below and join. So now mark these corners and this dimension is given for us which is 25 mm. Let me call this as A, B, C, D and E. So this is X and we have VP, HP for first angle projection. Now take projection and draw the front view. We know that front view is always a straight line. So therefore draw a straight line here. So drawn. Now mark, this will be A dash, E dash is invisible. We have B dash, D dash is invisible and we have C dash. Since the laminae is resting on horizontal plane, in the second position I should show inclination with respect to horizontal plane itself. How much is the inclination of the laminate to horizontal plane? He has specified it as 60 degrees. So therefore I will mark A dash, E dash and measure the length of the laminae. Measure the length of the laminae and transfer the laminae at an angle of 60 degrees to HP. Transfer the laminae at an angle of 60 degrees to HP which is given in the question. So transfer it. Transferred. Also transfer point B dash D dash which I have already measured. So I will transfer point B dash D dash also. So therefore I have transferred B dash D dash and this is C dash. Now take vertical and horizontal projection and complete the sketch. So take vertical and horizontal projections. Here I have E and here I have A. Similarly, we have C here, and we have B and D here. So now we got second position top view, that is A, B, C, D and E. Now join this A to B, B to C, C to D and D to E. So this is the required top view in the second position, where the lamina is inclined at an angle of 60 degrees to HP, given in the question. Lamina is inclined at an angle of 60 degrees to HP. Now in the final position, I should show inclination with respect to vertical plane. He says that the edge on which it rests is inclined at 45 degrees to VP. So it is resting on the edge A dash E dash. So therefore AE should incline at an angle of 45 degrees to vertical plane. So therefore let me mark 45 degrees. Let me mark 45 degrees. Marked. So now draw 45 degrees. Drawn. So this inclination is given for us in the question. One important note is that we are inclining the resting edge. The resting edge in the initial position measures 25 mm. In the second position also it is measuring the same dimension, 25 mm. So no need to go for beta angle. If the dimension is keep reducing from position to position, we should go for beta angle, that is apparent inclination with respect to vertical plane. Since here also it is 25, here also it is 25, no need to worry. Now we know how much is this. This is 25 mm. So mark 25 mm on this line. I have drawn 25 and call it as E and E. Now we know that C is a perpendicular bisector of AE, and how much is this? You are getting, you measure and transfer. That is, since it is a perpendicular bisector, divide this 25 mm into 12.5, 12.5 on either side and transfer the point C, which is perpendicular to this. So I transferred C. Now using compass you can transfer B. So from here you measure B, draw an arc. Similarly here you draw an arc for D. Ensure that this lamina should not enter vertical plane. Next here we have D. So intersect this arc. Here also you intersect B. So you'll get somewhere here. I have ensured that it is not entering vertical plane. So if so, then bring this AE further downward. So now I can mark this as D, this as B, and we have C connected to D. So A, B, C and D, this angle is specified as 45 degrees. 45 degrees. Clear? Now take projection and complete the drawing. So E is only till here and A is also only till XY line, and we have D up to midpoint and B is also up to midpoint and C is the farthest. So take horizontal projections now. So C dash, intersection of C will give us C dash, B dash and D dash you transfer. So this completes the final position, wherein which we have E dash, A dash, B dash, C dash and D dash. So join the respective corners to complete the required final front view of the given problem, wherein which it is resting on the edge A dash, E dash. So this is the solution for the the problem what he has asked, this is y. So this is the complete solution for the problem number 15. You can give 4 different solutions, that is you can incline this downward, you can plot C here and solve, you can incline 45 degree like this and give 2 more solutions. So all the 4 solutions are correct for the any given problem on orthographic projection of plane surfaces unless otherwise he clearly specify. If you take 45 degree this way, that is also correct. Take C downward, that is also correct. Further, taking 45 degree this way and giving 2 solutions, that is also correct. Whichever is convenient, you follow that method. Now let us move forward. The problem number 16 of our discussion states that a pentagonal laminae having edges 25 mm is placed on one of its corners on horizontal plane such that the surface makes an angle of 30 degree with HP and perpendicular bisector of the edge passing through the corner on which the lamina rests is inclined at 45 degree to VP. Draw the top and front view of the lamina. Now here we have the pentagonal lamina resting on one of its corners on HP. So I should get corner position. Let me solve this problem. Let us mark XY line. Let us draw XY line. Drawn. Let us call this as X. For first angle projection, we have VP above, HP below. It should rest on one of its corners. So therefore, I will take edge towards right side. We know how much is the dimension of edge. Edge dimension is 25 mm. So draw 25 mm towards right side and measure the interior and exterior angles on either corners. So interior angle is 108 degrees. Interior angle is 108 degrees or 72 degrees exterior angle. Similarly at bottom, this side will become interior angle. So interior angle is 108 or exterior angle is 72 degrees. Marked. Now lay down the edges. The edge dimension is known. The edge is equal to 25 mm. Here also the edge dimension is known. The edge length is equal to 25 mm given in the question. So draw the edge. Now using compass, you draw arc to complete the drawing. From here you intersect this arc. From here you draw the arc. Now join these corners. And mark. So here we have A, B, C, D and E. Now take the vertical projection. Before that, let me mark the dimension of this one. So this is measuring 25 mm given its dimension here. So now take vertical projections. From all the corners you take vertical projections and draw the front view. Let me draw the front view. So this is the front view. We have A dash, B dash is visible, E dash is invisible. We have C dash, D dash is invisible. Correct? And this is the required lamina what we have. Now what he says, since the lamina is resting on HP, I should incline the lamina to HP itself in the second position, that is rest on corner on HP such that the surface makes an angle of 30 degree with HP. So this surface is making 30 degree with HP. So therefore I will mark the corner A dash and measure 30 degrees. Measure 30 degrees. Measured. Now transfer the lamina. Transfer the lamina. Also mark B dash, E dash and C dash, D dash. So this angle is known. This angle is specified as 30 degrees given in the question. Now take vertical and horizontal projection and complete the drawing. So take vertical and horizontal projections. Take horizontal projections. So this will become E dash, we have D dash, we have C dash, we have B, and we have A. So he is clearly stating that the bisector passing through the corner on which it rests should be inclined to vertical plane. So therefore I want the bisector, let me call this as M1. Now let me call this as M2. We have E, A, B, C and D. Now join these corners to get the second position, top view. A to B, B to C, C to D and D to E. Now the careful observation reveals that AM1 is not equal to AM2. So therefore the perpendicular bisector passing through the corner on which it rests is inclined at 45 degrees to VP does not holds good now. So 45 degrees is given for AM1, which is not correct for AM2 because AM1 length is not equal to AM2. So therefore I should determine apparent inclination now, which is nothing but beta angle, that is apparent inclination with respect to vertical plane. Let us construct beta angle. You know how to construct beta angle, which I have already explained to you. Let me construct beta angle now. First let me draw the true inclination and true dimension. True inclination is 45 degrees. He has given. Draw the true inclination first, which is 45 degrees. Measure 45 degrees and draw a reference line which gives us true inclination. So 45 degrees drawn. On this, lay down the true dimension, that is AM1. Measure AM1 and mark AM1 on this. We fix point A here, M1 will be here. So this is A and this is M1. So AM1 length is known. I have inclined AM1 for given length 45 degree. So this will give us new locus of M. So fix the locus of M. So I got locus of M. Now using compass you measure AM2. Now keeping at A, you cut the locus and find M2. So I got M2. Now join these two, extend it back to find beta angle. AM2 is joined, extend AM2 to cut XY line. Now measure how much is the angle. Here you keep it and measure how much is the beta angle. So I am getting beta angle as 55 degrees. So I am getting beta angle as 55 degrees. I got beta. So I found that beta angle is found to be 55 degrees. Beta angle is calculated as 55 degrees. So now I got AM2. The careful observation reveals that AM2 is a perpendicular bisector for DC. Correct? So therefore DM2 is 12.5, CM2 is 12.5 and AM2 is a perpendicular bisector for DC. So therefore draw a perpendicular line having a measurement of 12.5 on either side of M2. 12.5 on either side of M2. This will give us D and C. Correct? Sorry, this will give us C and D. Right? Now using compass you transfer B and E, measure AE. So cut an arc for AE and also for B. Now from C you measure B, from C you measure B, also from D you measure E, from A you measure B, so properly you cut an arc. Here also you cut an arc properly. So that will gives us 2 points, that is, this is B, C, D and E. Now join these points. We have A to B, B to C, C to D, D to E and E to A. So this completes the required final position top view. Hope you understood. Now take vertical and horizontal projections and complete the drawing. So C is still above, so take the projection. B is still between and D is still above, farthest. Then we have, it is resting on A, then we have E. Now take horizontal projections to C and D and also for B and E, B and E. So therefore this is B dash and we have D dash, this is E dash, E dash, we have A dash and we have C dash. Now join these corners. That completes the required solution for the given problem. So it is resting on corner A dash. So join these points, these corners. So this is the required final position of the pentagon, where in which it is resting on corner A dash. Let me mark A dash here. Sorry, A dash is here, right? I done a mistake here. I'm extremely sorry for that. A dash is here. A dash is here. This is not A dash. So from here I should join A dash. So B dash, A dash, and this is E dash. So this is A dash. So we have A dash, B dash, C dash, D dash, E dash. So the pentagon is resting on corner A dash and the beta angle for this problem is found to be 55 degrees. So this is why. This is the solution for problem number 16. So this completes the problem number 15 and 16. That's all from this lecture. Thank you all.